We are looking at your review for your test on e to the x and ln of x, derivatives and integrals. Very simply, remember, the derivative of e to the x is just itself e to the x. Okay, ln of x, its derivative is always 1 over x. The way to think about it, whatever's on the inside here goes to the bottom, multiplied by derivative of the inside. E to the x, you rewrite the whole thing, multiply by derivative of the top. So be careful, if I give you derivative of 1 over x, it does not equal the natural log of x. Instead, think of that as x to the negative first power, and take that derivative. So derivative of x to the negative first is negative x to the negative second, or that would be negative 1 over x squared. So just be careful on that one. All right, number 4, ln of x over x. This is a quotient rule. So low d high, so low times derivative of ln of x is 1 over x, minus the high times d low times 1, all over low squared. X times 1 over x is just 1. ln of x times 1 is just ln of x. So this would be 1 minus the ln of x all over x squared. Okay, let's look at some more derivatives. Okay, when we set exponentials, all we said to do was rewrite the entire thing and then multiply by derivative of the inside, derivative of the top, which is 4. For number 6, same idea, so now we have a product rule. So we have a 1 and a d2. So 1 times derivative of e to the x is just e to the x, plus the second times derivative of the first would be 2x. I would probably rewrite this to put the 2x in front. This part should be all right. Again, if you had a multiple choice answer on a test, I'm good with this guy, but they might pull out an x e to the x, which would leave you with, what, x plus 2. That might be how they would be putting on an AP test, so just so you are forewarned. Okay, number 6, a natural log problem. To take that derivative, just put what's on the inside on the bottom, and then multiply by derivative of the inside, which is 2x plus 4. And I might simplify that just to make it one fraction, 2x plus 4, all over x squared plus 4x. Okay, number 8, we have another quotient rule. So we're going to go low times d high. So rewrite the low. D high is 2x minus high d low. High is x squared. Derivative of the bottom. Well, to do that derivative, I have to rewrite e to the 4x, but I also have to multiply by derivative of that top. So times 4. So a little chain rule just for the derivative of the bottom. All over low squared. So e to the 4x, the whole thing squared. I should try to simplify this a little bit. When I do, I should have the top would be now 2x e to the 4x minus. This will be 4x squared e to the 4x all over. This would be e to the 4x squared, which would make it to the 8x. If you got to this point, I'd be happy. You should also probably notice, though, you have an e to the 4x everywhere. So I can get rid of one of those everywhere, and that would give me an answer here of 2x minus 4x squared all over e to the 4x. If you can get to this part, though, I'm pretty happy with that. So there's your derivatives, and again, remember, just e to the x is itself. The natural log of x goes to 1 over x. Put what's on the inside on the bottom. So now, integrals, and I know these are fun times here. So let's begin with the first couple here, just the basic ones. The integral of e to the x is just automatically e to the x, plus c, of course. And the integral of 1 over x is equal to the natural log of x. It really should be the absolute value of x, again, plus c. And again, be careful. Don't let me give you the integral of ln of x and you say it's 1 over x. That is not true. You only go from 1 over x integrating to get to the natural log. Okay, here's 3 more for us to look at now. In this one, ln of x over x. This is a bit of a tricky one right off the bat. What I'm going to say, though, is that if I make u equal to the natural log of x, that means we know du is 1 over x dx, and I can simplify that with dx equaling, it would be x times du. So now I can rewrite my integral as the integral of u over x dx is now x du. My x's cancel out. I have the integral of u times du, which is very easy to do. Increase the exponent by 1 and divide by the new exponent, plus c. always replace u with your original. So make it the ln of x, that whole thing squared, divided by 2 plus c. Number 12. I have something with an exponential. I can't do it as it is immediately, so what I'm going to say is that first of all I should look and say my exponent is likely going to be my u. So 3x squared will be my u. That means du will equal 6x, and that means dx, it should be 6x dx. Dx would equal du over 6x. So that means I can go now rewrite the integral. I didn't change the x. I didn't change the e, but I did change its exponent. It's now u. And dx now reads du over 6x. My x's should cancel out. I'm going to bring the 6 out in front. It's on the denominator, so it's going to stay on the bottom in the denominator. All that's left is e to the u du, and this is really easy. The integral of e to the u is just itself. Remember, I have not taken an antiderivative yet, so do not get rid of your integral sign. But now I am going to take it, so keep the 1/6 in front. When I get rid of the when I take the antiderivative, now I get rid of the integrand. So now it's e to the u. The du goes away and becomes plus c. And we always finish it off by going back in terms of x, so plug that back in for u. So 3x squared, e to the 3x squared now, plus c. Alright, in number 13, if you'd be looking for a u, you'd probably say either e to the x or 1 plus e to the x. Well, this one actually is a lot easier than it looks. This is one of those heart problems. Try to break it up into 2 easier fractions to work with. So I'm going to have the integral of 1 over e to the x and e to the x over e to the x. Well, that part should be easy. The e to the x over e to the x is just going to be 1. This, I don't like things on the bottom, so I'll bring it to the top by changing the exponent to a negative. So e to the negative x plus 1. Excuse me. So e to the negative x, if you're unsure, think about a u substitution maybe. U would equal negative x, means du would equal the negative dx. So this part would mean just that dx again equals negative du. So you can break this up into 2 different integrals, 1 integral and 2 integrals with the dx in each. So the first guy here would now become, I'll write that part in pink, would be now the integral of e to the u, and this would become du, dx would become a negative du, so this would just be a negative integral, and then still plus the integral of 1 dx. I can solve each of these separately, which is what's beautiful about integrals, solve everything separately. This would become negative e to the u, this would become just x, and I always have to put things back in terms of x, so negative e to the negative x plus c. Now, you probably could have even realized straight from this part right here that, okay, it's going to be e to the negative x, but when I would take a derivative back, I would need to have a negative sign there. So you could have gone even that route to have gotten that negative e to the negative x part. There's lots of different routes that you could have gone for solving this one, but the main part that I want you to notice is your little heart problem from the beginning. Our next set here, okay, want to look at the fact I have 2 things, nothing on the inside, but one part should be the derivative of the other. If I took the derivative of the bottom, I would get the top. That means the bottom needs to be my u. So u equals 3x squared plus x, and that gives you du of 6x plus 1. So if you want to use this, 6x plus 1 dx, so that means dx would equal du over 6x plus 1. Now, what I would notice here, I'm going to go 2 different steps with this to get to the same idea. I could rewrite everything. I didn't change the top. The bottom became u, and this dx became du over 6x plus 1. And what I would notice is those would cancel out, and it would give you the integral of 1 over u du. What I also could have noticed is, well, this whole part right here is what I just wrote as du. So I could make the top be du and the bottom be u. Well, guess what? That simplifies to be the exact same thing. So either way, I have the exact same idea, the integral of 1 over u du. And the integral of 1 over u is the natural log of u plus c. And of course, plug back in, so the natural log of 3x squared plus x plus c as your final answer. All right, 15. Again, we have an inside and an outside. We have an inside part, so that's 99 times out of 100 going to be my u. Du here will be 2x dx, which means that dx equals du over 2x. So let's rewrite this. This is now going to be the integral of x over, I didn't change the top, so I did change the bottom though, make it u cubed. And dx now reads du over 2x. X's cancel out. It leaves me with a 2 out here, but it's on the bottom, so it comes out as 1/2. 1 over u cubed du. Now, what you're going to do, and I'm going to try to trick you on this, and so will the AP test. They want you to say that this would equal 1/2 the natural log of u cubed or something like that, or even squared if you think increased by 1. Not the case. The only time it's ln of u is if this is just 1 over u, period. No exponent. This has to be just u to the first. So what you're going to do instead is treat this like a regular power rule. Rewrite it first as the integral of u to the negative third du. Now take your antiderivative. Keep the 1/2. Increase the exponent by 1, so u to the negative second. Your denominator is your new exponent. From here it's simplifying. So negative 1 over 4, u to the negative second. It should be plus c in here. And then always finish off by changing back into x. So negative 1 over 4. This will become x squared minus 6 all to the negative 6 power, or to the negative second power, plus c. Again, if you want to rewrite it, you can put this back in the denominator with a positive exponent. So it would be x squared minus 6 squared. Keep that 4 from your denominator, and your plus c as well. Again, this is the part I'm looking to definitely make sure you get to. Last three. Number 16. What I'm going to look at here, again, each one is very similar. 9 times out of 10, whatever has the extra term here is going to be my u. Because when I take this derivative, the minus 1 goes away and will give me something like the top. du here is going to be negative e to the negative x. Because I rewrite the e to the negative x, but I have to multiply by derivative of the inside. So that's how I get e to the negative x dx. That means dx is now du over negative e to the negative x. Simplifying time. So, it's now the integral of, I didn't change the top, my bottom is u, and dx now equals du over negative e to the negative x. Excuse me. So, I have things canceling, e to the negative x, and be careful. You'll probably forget about this negative sign. Don't forget it. It's just like a number, like a negative 1. You must bring it out in front. So I'll bring the negative out in front. I still have the integral of 1 over u du, which again is just the natural log. So keep the negative, actually take the antiderivative, the natural log of u plus c, and then always change back into your original variables. So e to the negative x minus 1 plus c as your final answer. And again, I would probably be boxing all these answers as well, just to get in that good habit. Alright, 17 and 18 are just some extra practice with a definite integral. So for this one, I don't know e to the 2x, but I do know e to the regular x. So let's change the variable to make it just e to the u now. So du will u will equal 2x, so du equals 2dx, which means again dx equals du over 2. So just like before, we're going to make this now e to the u. It's now du over 2, excuse me, which I can rewrite as bring the 1/2 in front, integral of e to the u du. If you like changing your limits, you would do that. If x equals 0, that means u equals still 0. When x equals 4, that means u equals 8 now. So your new limits would be 0 and 8. I can take this antiderivative as just e to the u and evaluate it from 0 to 8, which would give me 1/2 of e to the 8th minus 1/2 of e to the 0. Well, anything to the 0th power is just 1, so I would write that as 1/2 e to the 8th minus 1/2. Or this would be 1/2 e to the 8th minus 1 if you factored out and just evaluated with that part. Now, your other option here, if you went back to your original, you would ignore these numbers the whole way through. You would get to this part right here, 1/2 e to the 8th, e to the u. You change it back to be 1/2 and make it e to the original, 2x, and evaluate that from 0 to 4. And you get the same thing. You'd have 1/2, and you would have 4 times 2 gives you 8, so e to the 8th, minus e to the, when I plug in 0, e to the 0. So 1/2 of e to the 8th minus 1. Alright, and my last one down here. The integral of 1 over x is just the natural log of x. So I can just do that immediately. But I'm going to evaluate this at two numbers, at 1 and at e. So when I plug this in, I'll have the natural log of e and a natural log of 1, and I'm going to subtract those. Well, the natural log of e, remember, those are inverses, so that's just 1. And natural log of 1 is just 0. So 1 minus 0 gives you your answer of 1. So there you have all of your answers here for the entire thing, for integrals, derivatives, everything you need with e's and ln's, and a partridge in a pear tree.